I'm very pleased to introduce our next speaker, who is Professor Keith Fox. Keith has been involved with the Faraday for many years. He was our previous director. He was associate director, line manager for years and years. And today he's going to speak on his academic subject. Keith is also professor of biochemistry at Southampton University. He works on DNA, and he's going to talk to us about bioethics and genes. So over to Keith.
Thank you, Sarah, and thank you, everybody. It's good to be with you this morning. Let me just see if I can get my slides to share. Well, it seemed to work first time. I hope that it's working for me. I'll assume it is for you unless somebody screams at me. It is a pleasure to be with you. As Sarah says, I'm a mere biochemist who fiddles with DNA. I happen to think that DNA is the most fascinating molecule in the universe. You might not agree with me on that, but it touches on some of the things that we're going to be talking about today. Where am I going to be going with all this? There we are. We'll tell quite a bit about genes and DNA testing and personality and what makes us the people we are. I'm aware that we're coming from a variety of different backgrounds, so at some stage we'll have to say something a little bit about what genes are and what they do. Those of you who are biologists, I hope you're familiar with that sort of thing anyway. We'll talk about genes and gene editing and disease and how we might use some of the technologies for correcting diseases, and then take that further as to whether we can use those technologies actually to enhance ourselves as humans, to have greater properties. And all of this, of course, will ask the question of what it means to be human. Thinking about this as Christian leaders, of course, there are no scriptural proof texts to help. The writers of the scriptures knew nothing about DNA, let alone about cells or the sort of things that we talk about. So we need to be thinking about more general principles of how we think about these things as Christians. And in many of the things I'm talking about, I'm going to raise issues and then leave you to make your minds up one way or the other. We also need to be aware that some of the things I'll talk about might appear to be science fiction, things that we can't yet do, but we can imagine. And it's worth being aware that today's science fiction very quickly becomes tomorrow's science fact. And it's as well for us as Christians to be thinking ahead about these issues rather than trying to play catch up when everything's already happened and it's too late. But let's take a step back a moment. It was said yesterday, the wonders of science. And as we think ethically about the applications of science, sometimes Christians can be seen as the group of people who like to say no. And we have what appears to be a very negative attitude to things. So I want to reinforce at the start that how wonderful science is as God's gift to us that enables us to explore the world that he has created. And that science itself is often to do with just understanding the way the world works, and it's ethically neutral. But of course, the application of the science and those scientific discoveries often has profound ethical implications. Let me go back and ask a question about what makes us who we are. I'm skipping ahead of myself. One thing again is that I think Paul mentioned this yesterday of Augustine saying, make sure you know what you're talking about. It's very easy for us to have a superficial knowledge of some aspects of the science and shoot from the hip and make quick decisions one way or the other without knowing what we're talking about. So it is quite important that we understand the science as well as the ethics in order to be able to make an informed Christian opinion of things. I said I want to look about personal identity. There's me. It's a rather younger version of me than now. What makes me me? The genes that I have, how many of the things that I do and think and the way that I behave can I blame on my predecessors, my ancestors? There's 6 generations of males in my family. And I think I have some foibles, and how many of those can I blame on my ancestors, my father and grandfather, etc.? And right at the top is my son, and how many of the things that he does that he's ashamed of can he blame on his father and my genes? Our profession, our appearance, our character, five of those, were born in Bristol. One was born in Cambridge. You notice a progression as we go across there. Let me see if I can get a pointer for you. From bow ties to neckties to no ties. There is development across the generations. How much of that's me can I blame on them and their genes, and how much am I responsible for myself? Can I blame my genes? The Nobel Prize winner James Watson, who discovered the structure of DNA, has said, we used to think that our fate was in the stars. Now we know in large measure that our fate is in our genes. How much can we blame on our genetic makeup? There are plenty of companies who do direct-to-consumer DNA testing, and I wonder if any of you have indulged in that. Or my guess is that people within the congregations that you minister to will have tested those. 23andMe and Ancestry.com are probably the best known amongst those. There are plenty of other them. Some of them have a higher reputation than others and give better testing. In fact, one of them was advertising, why not give away a DNA testing kit as a Christmas present to your family so that they can find out things about themselves. It sounds great fun. I must say, beware of that. There have been families whose relationships have been ruined by finding out things from their DNA of skeletons that were lying in the cupboard that were best not discovered, and relationships ruined as a result. So think very carefully if you're tempted to find out things about your ancestry, etc., from DNA testing. But I wonder why people would want to do that, to find out some of their things that are hidden in their DNA. Well, one way is to identify the risk of diseases and maybe to change their diet or their lifestyle because of that. One of those companies surveyed their customers and said that 76% made healthier choices as a result of that. Eating a healthier diet, setting healthier life goals, taking greater exercise. So it seems like it's a good thing, but the converse of that is sometimes we find out things in our genes and we become the worried well. Afraid of things that might happen to us. Or alternatively, we actually become fatalistic. We say that we've got a gene that might give a particular disease, maybe a heart condition, etc. And so, oh, well, no point in bothering, I'll just carry on. We might do those sorts of things out of curiosity. Just a bit of fun. We might want to find out something about where I come from. There is some variation across the globe and even more locally that you can find out things about your ancestry. But if you did get all that information, would you actually understand the result? I struggle with it, and I'm a biochemist who plays with genes for a lot of my life. The public don't understand a lot about it. And this is an example. This is not meant to be a party political point, but how we can misunderstand the information that comes from this genetic testing. So our previous health secretary was tested, and the test showed he had a 15% risk of developing prostate cancer by the age of 75. And his comment was, the truth is, this test may have saved my life. And at face value, that sounds a reasonable thing to say. However, the average lifetime risk of developing prostate cancer for men of his sort of age is actually higher than that. So his risk of developing it is lower than the national average. And a professor of genetics commented his claim that this test may have saved his life is frankly ridiculous. It demonstrates an astonishing and worrying degree of innumeracy and lack of comprehension. And that's not to make a party political point in that, it's just to show that we don't understand. What other things might you find out? Alzheimer's, it has a genetic component to it. There are plenty of things that influence Alzheimer's disease, the various forms of what's called the ApoE gene. We all have 2 copies of it. They can come in one of 3 different forms, and those forms affect your risk of developing Alzheimer's. But be aware that those things are probabilities. They're risks. They're not certainties. It's not absolutely sure that you will develop Alzheimer's if you've got one of those, or you won't if you don't have one of them. And who wants to know anyway what their ApoE status if there's nothing you can do about it? There are no cures for Alzheimer's disease, so maybe ignorance is better in those sorts of things. What is it that's in our DNA? The phrase "it's in their DNA" is bandied about by all sorts of people. The media love to think that various parts of our personalities and our habits are genetically determined, and they pick up on a little bit of the scientific literature and rather exaggerate it and take it out of context. So here's a list that was compiled by my colleague Dennis Alexander, former director of the Faraday Institute, of the love cheat gene, the gangster gene, the mean gene, political behavior genes, cigarettes, it's all in your genes, the gluttony gene, the liberal gene. These are all exaggerations. There are no such things as genes for any one of those. There may be genes that influence our behavior in small ways in each of those attributes, but there is no such thing as a gene for each of them. It's a phrase that is bandied about. Companies use the phrase, "it's in our DNA to do some." I've heard preachers use the phrase, "it's in our DNA." I plead with you, please don't use that phrase, because it suggests actually that we're determined and we have no choices. DNA, as we will see, is not quite like that. So if I can get one thing across today, if you're a preacher, please don't use the phrase, "it's in our DNA to do something." What is a gene? Well, a gene is essentially a region of DNA that codes for a protein or regulates the way in which that protein is used. They're typically between 1,000 and 1,000,000 base pairs long. A basis of those things, A, G, C, and T, that are ordered in a very precise way in our genomes. And many genes are arranged on each chromosome. And there are plenty of gaps in between the genes. In fact, most of our chromosomes, we don't know what they do. As a matter of hubris, a few years ago, people called it junk DNA. Actually, it's not junk. It's just that we don't know what it does. Those genes are arranged in our 23 different chromosomes, and there are about 20,000 genes in a human, very similar to the number in a worm or a fruit fly. We have about 3 billion, that's 3 with 9 noughts after it, of those letters in total in our genome. And every cell in your body contains exactly the same DNA. It's slightly different from the person next to you. On average, we differ about 1 in every 1,000 of those letters from the person next to us. And different ones of those genes are switched on in different tissues. So though the DNA in your big toe is exactly the same as the DNA in your brain, different genes are switched on in each one of those tissues. And the DNA, the genetic code, is universal. So bacteria, plants, animals, humans, we all have the same basic chemical molecule of DNA. The sequence of those letters is different for each one, but the fundamental principle is the same. And because of that, it means that we can move it around from one organism to another one, from one bacterium to another, from a bacterium to a plant, and into animals and humans as well, at least in principle. So that raises the whole question of genetic modification and the issues that raises. People say, well, are we playing God in doing that? Are we messing around with what is natural? And that raises the question of what actually is natural. Are we risking doing things that we don't understand the consequences? And should there be boundaries between different species? This phrase, playing God, is one that's frequently used, and it suggests that there are limits to what humans should do, that there are things that boundaries that we shouldn't cross. And rather worried that we use the term playing because I don't think most of my scientist colleagues are playing. I think they're being rather serious in the way in which they're doing their science. Science is indeed good fun. I do enjoy doing science, but it is serious work, not just having fun. We're made in the image of God, as several other speakers have already said. God is creative. Does that mean that we too should be creative as those made in his image? And as we think about the ways that we might use this for positive effect, we need to remember that healing and restoration and feeding of the poor have always been part of the Christian's duties. And maybe we can use some of these technologies to good effect in order to do that. What does DNA, how much of it makes us who we are? There's a rather interesting book by Robert Plomin, who is a very influential geneticist, Blueprints, How DNA Makes Us Who We Are. And he puts in that DNA isn't all that matters, but it matters more than everything else put together. And he says at one stage in there, nice parents have nice children because they're all nice genetically. That is a vast overstatement. You will be aware of plenty of nice parents who have children who don't turn out particularly pleasantly at all. These are things that are based on what's called genome-wide association studies. In other words, examining the DNA of many hundreds of people and building up probabilities. These things, therefore, are probabilistic. They work on populations. They're not deterministic. And as they work on populations, they actually don't necessarily work on individuals. They can say things about probability and risk. They cannot say anything about determination. So can I blame my genes? Well, genes limit our potential. They may affect what we can do, but we still remain responsible for our actions. You see, DNA is not a blueprint, and that's a phrase that's often used to describe it. It contains information needed to produce proteins. It's a polymer. If I was to put it on the bench and show it to you, it would look like a piece of tissue paper that's gone through the washing machine and been dried out at the end. It's just a white clump. And the genes that has are part of complex systems. The DNA on the bench does nothing except slowly decay. It only does something in the context of the cell, and the cell only does something in the context of the organism that's placed in, and the organism actually only does something in the context of the community in which that organism exists. So DNA contains information, but it needs to be combined with developmental and environmental factors to facilitate the growth of that cell into a multi-billion cell person. There are trillions of cells in each one of our bodies. We run the risk of what I call genetic reductionism, a sort of genes are us fallacy, that we're nothing more than our genes. We make our DNA into a kind of God. We can't dare tinker with it because of its sacred qualities, suggesting that we are nothing more than the sum of our genes that dictates everything about us and subscribes to a kind of genetic fatalism. Many, scientists included, would argue that there are many more things than our genetic makeup that make us uniquely human. It may limit our abilities, but we're much more than the sum of our genes. And here are scientists writing in the journal Science. We're in the age of the genome, they say, but we can still recognize it takes much more than genes to make a human. But yet our genes do affect the things that we do, maybe even the things that we think and the way that we behave. Here, I'll just give you a few examples. An association between genes and political ideology is claimed. And look at the journal this is published in. This is published in the Journal of Politics, not a science journal at all. That variations in a certain neurotransmitter and its receptor can affect people's political thinking, they claim. And there's an article published in the top science journal, Nature, which I take exception to. And within that, it says an increasing number of studies suggest that biology can exert a significant influence on political beliefs and behaviors. And genes can exert a pull on attitudes concerning topics such as abortion, immigration, the death penalty, and even pacifism. And it goes on to say it's difficult to change someone's mind about political issues because their reactions are rooted in their physiology. Well, that's a vast overstatement and exaggeration of what might be some trends. If that was true, don't ever bother trying to change somebody's mind. Don't ever try to persuade somebody of the truth of the Christian gospel, because according to that, it's all in their genes and it's fatalistic. But if you believe in that kind of ultimate genetic determinism, it leads to what I might call conservative with a very small c political ideologies, because if our human nature is determined by our genes, then we can't change society by changing social structures. The problems then lie in the individuals and their genetic makeup who make society. And the solution, therefore, is to change the genes or even to eliminate the individuals, not to challenge existing social structures. And we get to something, extreme right-wing solutions. If we took that to an extreme, now nobody does, but I hope you can see the implications of that. What if we could use our genes to make us better? Here's an article published in 2009, before many of the gene editing technologies that we now have became available. Improving morality, it says, by genetic engineering. And there's a paragraph taken from this. And the italics in this are mine to show just how much it's exaggerating. It says nearly all personal traits show moderate heritability since genes influence enduring behaviors. It might be possible to use biotechnology in a manner that would promote virtue and thus serve as a means to improve ourselves, morally speaking. So would you want to have your genes altered to make you a better and nicer, more ethical person? I think that rather takes away our sense of personal responsibility and again, suggests that everything is rather deterministic. As I say again, we're not defined by our chemical makeup. Actually, as was, I think, said by Graham in the previous talk, our relationships together are important. It's an African proverb, a person becomes a person through persons. So just as DNA does nothing in itself, except in the context of where we put it, so we too are defined by relationships. And we find our true identity in our relationships with God, who knows us, gives us identity, worth, and significance. And those are worked out in our relationships with each other. So those interactions are really very, very important and are far more than just the sum of our genes. But as we start to think about maybe gene editing and what we might be able to do for benefit or for ill, let's take a step back and think about some of the implications of in vitro fertilization. That is the process by which an egg and a sperm are combined outside of the body as they combine to make this single cell, the zygote, that then divides. One goes to 2, goes to 4, goes to 8, a bundle of cells that then start to differentiate to make different tissue types. And that can then be implanted into the woman to lead to conception. Well, it's a process that's been used for those who have difficulty conceiving. What about the unused embryos? Far more are generated than are needed. Well, they're stored. Well, they're stored for how long? And then what? What should we do with those excess embryos? Are they really people? Are they people waiting to be born? Because of their use, you can get strange generations. They don't have to be implanted back into the person who generated the egg and the sperm in the same. It can be put back into the mother of the person who provided the egg. So you have, is that then the mother or the grandmother of the child that's born? It raises strange issues, which I don't want to go into within this. But it's used for also for detecting various genetic conditions. If the parents are known to be carriers of what might be even a fatal genetic or a serious genetically inherited disease, we could test the embryo to see whether that has the disease itself. It's possible to take this small clump of cells in the 8-cell stage, to remove one cell, to test it, so look at its DNA content, and if it's diseased, then you don't implant it. If it's the healthy one, then you implant it and you hope it leads to conception and to birth of a healthy child. But that raises the question again of when does an embryo become a person? The sperm and the egg that make that zygote, that early embryo, is that a person? It lacks any recognizable structure. It looks like a clump of cells. And actually 50% of those zygotes under normal fertilization don't implant and lead to conception. And at that stage, actually, that clump of cells can divide and become two persons. That's how identical twins arise. If those who think that the embryo has personhood, an ethical conundrum that's raised is if you have one of these freezers that's storing many of those embryos and there was a fire and you had the choice of rescuing a young child, one young child, or rescuing a freezer that contained hundreds of these early embryos, which would you choose? I would choose the child without a moment's hesitation. There are various views on the early embryo. Some would say it is a human person and destroying it is exactly the same as abortion. And those in the extreme of the pro-life would take a view against in vitro fertilization, rather the disposal or the use of those embryos. Others say it's not a human person, but it has the potential to become one. And we'll say that there's a difference in the status between the pre and post implantation of embryos. Once it's implanted, then that has greater potential to lead to a birth. And others will say, well, the early embryo is just a clump of cells. It's not a person at all. It's just a biochemical mass of information. And there are extremes of that within all branches of the Christian faith. You could find evangelicals and liberal Christians who take opposing views on those sorts of things. So it doesn't fit with any form of churchmanship. You have to make your own mind up on that. But to come a little bit closer to how we might use our genetic technologies and maybe interfere with the behaviors of those early embryos for good. Let's face it, life isn't fair, is it? Some people are born with real advantages over others. They've got athletic ability, musical ability, they're intelligent, they're attractive. Others are born with profound genetic disabilities and disease. Wouldn't it be nice if we could level the playing field? To make sure that everybody has a good set of genes. And we might do that maybe by not introducing new genes, but by just optimizing the distribution of them, so that we all get the best combination of natural genes that are out there. Sounds good, doesn't it? It sounds as though we're leveling up. We're giving everybody equal genetic opportunity. You see, there are between 4,000 and 6,000 diagnosed genetic disorders, and there's probably many more that we haven't properly diagnosed. And they say that about 1 in 25 children is affected by a genetic disorder. Some of those have life-changing consequences that are immediate as soon as the child is born. Others may have consequences lying in the future as to whether they might have a greater risk of developing cancer or with Huntington's disease or some other neurological disorder. All of those are hidden within our genes. Wouldn't it be nice if we could change that? And here's a list of some of them: cystic fibrosis, Fragile X, hemophilia, Huntington's disease, etc., etc. And it's quite likely that somebody within your congregations, your church communities, will possess one or other of those. I'd be surprised if you didn't know somebody who didn't have any one of those. So the human genome is over 3 billion of those letters long. And sometimes a change in only one of those letters, 1 in 3 billion, can have devastating consequences. I mean, here's an example of sickle cell anemia. the gene for one of the hemoglobin molecules. A single change of a letter from a T to an A at one point in all those 3 billion leads to a variation of the hemoglobin structure that leads to sickle cell disease. Wouldn't it be nice just to be able to change that back again, to take those sufferers and put that A back to a T, and so alleviate the disease? What if we could do that? A sort of molecular cut and paste, scissors for taking out the defective and replacing it. Well, until recently, that was science fiction. But over the last 5 or 10 years, this has become practical. And there's 3 major technologies: TALENs and ZFNs, or ZFNs, I suppose, because the Americans tend to dictate the terminology. And more recently, this thing called CRISPR, which is an extremely powerful technique that can be widely used and is easily adapted to all sorts of different genes. We needn't go into what those abbreviations stand for, but they give us the opportunity to be able to cut a piece of DNA out at will and replace it with something else. I won't go into any of the details of the biochemistry. It is fascinating and complicated. And here's a book by John Parrington in Oxford, Redesigning Life. And he says in that every once in a while, a scientific discovery is made whose impact on society is likely to be so immense that even an abundance of superlatives may not do it full justice. Genome editing looks set to be such a discovery. And the discoverers of that were awarded the Nobel Prize just a couple of years ago. It's a remarkable technology. And it's been used to great effect. Those of you who watched the 10 o'clock news on the BBC last night may have heard about people being treated for cancer by this CAR-T technology, which really is a means of taking cells out of their body, modifying them with that technology, and putting them back in again. And there have been some moving examples of that. This girl, Layla Richards, was in the terminal phases of a form of leukemia before that technology was applied to her cells, put back into her, and she was in remission. So remarkable technologies that can be done on whole human beings. This is what's known as somatic cell modification. That occurs in our body cells. It affects only the individual that's involved. It cannot be passed on to offspring. And of course, the individual, at least they're an adult, has some choice in what's done. It's rather difficult to do, though, because we said there are trillions of cells in the human body, and in many cases, delivering this sort of technology to those cells is rather difficult. There are technical issues around them. In some instances, modifying just a few cells is sufficient to overcome disease. More powerful, though, would be applying the technology to germ cells, that's eggs and sperm, or to that early embryo when you've only got to modify one or a few cells. And that will affect the individual, but also will then carry on to all future generations. It'll be done by in vitro techniques, and then in vitro, similar to in vitro fertilization, will be implanted and lead, one hopes, to the birth of a healthy human. What can it be done? Well, here we are back in 2015, the first example of it done on human embryos, not for implanting. These were embryos that could not have led actually to a healthy human. They were tripronuclear zygotes. That's actually the very rare occurrence when an egg cell reacts with 2 sperm. It is not totally non-viable, and they showed that they could do this. And then the technology developed, and in 2018, there was public outcry by this Chinese scientist who claimed the first gene-edited babies, that he altered the DNA of twins, he called Lula and Nana, to prevent them from contracting HIV. A fascinating, clever piece of work, but widely condemned within the scientific community. Condemned for all sorts of reasons. Firstly, the risk. There's always the question, if you modify one gene, maybe you're going to modify other ones by accident at the same time. The technology, although very powerful, does make mistakes. In this case, it was unnecessary. It wasn't a therapeutic application. It wasn't to cure HIV. There have been inappropriate ethical approval, inappropriate informed consent. It was a form of enhancement, if you like, and it leads to things like eugenics and maybe commodification of children. So it was widely condemned in the scientific community, and there is in general a moratorium on doing that sort of thing to lead to implantation and the birth of a child. But on the other hand, there are many harmful genetic mutations that it would seem like an ideal outcome them to prevent those genetic diseases. And the questions raised, and I put some of them in the previous slide, what are the risks of doing it? What about consent? The early consenting. But what about, does it say to those who have already been born, who have not been corrected? What does it say about them? Is the fact that we cure the newborn that at the single cell level, does it say to those who already been born, wish you'd been corrected? We wish you weren't the way you are? What is normal? And is it the slippery slope to human enhancement? In fact, in many cases, that form of technology for curing single gene diseases is unnecessary because you can select the healthy embryos anyway from the pre-implantation genetic diagnosis I mentioned earlier on at that H cell stage. There are a few exceptions when there are no healthy embryos that can be implanted, in which case the only way of generating a healthy one, especially if there are multiple defective genes, is in this editing technology. But here's Francis Collins, a lovely Christian who until at the end of last year was director of the National Institutes of Health in the USA, commented on the NIH's behalf, the strong arguments against engaging in this activity remain. These include serious and unquantifiable safety issues, ethical issues presented by altering the germline in a way that affects the next generation without their consent, and a lack of compelling medical applications. But is this just a form of embryo healing? After all, Christians have been at the forefront of healing, restoration, feeding the poor for many, many generations. We're used to organ transplants now, aren't we? Heart transplants, liver transplants, not that they're trivial, but we're used to doing it. Is this just a form of DNA transplant? Is it playing God? Well, I think it's more than just a DNA transplant because of the risks involved in it and because of the effect on other generations as well. But on the other hand, is it part of the God-given arsenal that we have? The way in which science has given us that gift of, God has given us that science to enable us to alleviate human suffering. And I'm cautious sometimes because of the way in which the Pharisees responded to Jesus. Remember when he healed on the Sabbath and they said, you can't do that. And he replied, is it lawful to do good or to do harm on the Sabbath, to save life or to kill? And maybe we should not accept disease with a sort of misplaced fatalism that sees everything as God's will. We should strive to be curing disease and for alleviating suffering. Where would we stop if we could do it? Should we modify the genome of an embryo that will otherwise die of a genetic disease? I think that's giving life where there otherwise would not have been. That sounds like a very good and positive thing. Should we modify the genome of an embryo that will, say, have a life-changing but not life-threatening disease, such as cystic fibrosis? Should we modify the genome of an embryo that will develop a disease later in life, such as Huntington's disease, an awful disease, for which the person may have 30, maybe 40 years of perfectly normal, healthy life, but then suffer from this awful degeneration? And of course, should we modify the genome of an embryo just for cosmetic reasons to change their eye color or other of their physical properties? To go back to the gene 4, there's often not a simple gene 4. We might want to enhance somebody's intelligence. There are genetic aspects to IQ, but it's many genes operating together. and said that there are 74 at least genetic markers that contribute to IQ, making a very, very small percentage change in that. So multiple genes combine together to have an effect. Similarly for diabetes or height, these things are genetically affected, but there are many, many genes that interact together to do that. In fact, for intelligence, you get a far, far greater effect by investing money in better education than in changing people's genes. And what does it say about those who are disabled? Here's Tom Shakespeare, who is a spokesperson for many disabled people. And he says people with disabilities are unlikely to be queuing up for genetic modification. Their priority is to combat discrimination and prejudice. The voices of people living with illness and impairment need to be heard, he says. Nothing about us without us. So how does society include people whose impairments will not simply be edited away? Are we saying to those, I wish you hadn't been born. You're a drain on our economy. You could have been edited. You could have not been born. And are we therefore reinforcing what we might be called an ableist mentality? It assumes that independence and physical functioning should be maximized, and that dependence and weakness and vulnerability are defects, that they're inherently bad. I think as Christians, we would want to argue strongly against that form of arguing. And in part, it relates a little bit to what might be called eugenics. It became popular towards the end of the 19th, early 20th century, but it has a long history of choosing those that you want to in society. One of the Roman laws in the 5th century BC said a father shall immediately put to death a son who is a monster, who has a form different from that of the human race, infanticide. And in fact, infanticide was fairly common throughout the Roman Empire until the advent of Christianity, that showed the worth of all people, regardless of their physical abilities. Became popular in the 19th century with Francis Galton, who was interested in improving the human stock to create better humans, as he put it. He feared degeneration, that the feeble-minded people, the weak, tended to reproduce more rapidly, and that we were therefore having a society that would be overrun with disabled or less able people. More popular in the US here, and there were fairs for these sorts of things. How long are we Americans to be so careful for the pedigree of our pigs, it says, and chickens and cattle, and then we leave our ancestry of our children to chance or to blind sentiment? And people were awarded eugenics prizes at local county fairs with the mistaken belief that many things are genetically inherited. And there were enforced sterilizations, especially of women who were deemed unfit. That included the poor, the mentally insane, the feeble-minded, as they had it, and even drunkards, to stop them from having children. And a rather famous court case in the US, 3 generations of imbeciles are enough, said the judge. And I think we would want to react very strongly against that. Are we in danger, therefore, in the way that we use genetic technologies of sidelining people who don't fit into our preconceived personal view or our social norms? Does it reinforce what is socially acceptable? Let me give you a couple of examples. And this is from the journal Nature. And this is very moving, I think, of a girl who suffers from a genetic form of albinism. It means she has very limited sight. And they asked her father if before she'd been born, you'd known that she would have that, would you have chosen to have her genetically edited? And he said, yes, I probably would have done. But then asked, now knowing the daughter that you have, would you now wish to have her, wish that you had had her genetically edited? And he answered, no. She is the person that she is. It would have been different. And they asked her, did she wish that her parents, if they'd had the opportunity, could have had her genetically edited? And she didn't blink. She said no. Changing her disability would have made us and her different in a way that we would regret it, her father said. And that's scary. What about those who are deaf? There's a form of genetic deafness. And there was a court case for deaf parents who wanted to select a deaf child. They would say that deafness isn't a disability, it's a culture. Should they be able to do that? The courts actually at the time said, no, you can only do a selection of embryos for positive effect, not for negative. But we do know that what seems like a disease and a weakness to some is actually a strength to others. And we could take the example of the Apostle Paul in his thorn in the flesh, whatever that might have been. Some say it was a form of epilepsy. Some say it was very poor eyesight. Whatever it was, Paul said that God's power was made perfect in weakness. So what seems like a weakness for some is a strength to others. And an overblown enthusiasm for genome editing may avoid the question of how society includes people whose impairment simply cannot be edited away, and we have then an inclusive society. It raises the question of what is normal. Human diversity is what it takes to make a society. The scriptural analogy of the body, where not everybody is an arm or an eye or a big toe. We are diverse. We are gifted in different ways. We even speak of an athlete's or a musician's gift, as there's a sort of contingency in that. Excellence consists at heart a display of natural talents and gifts that have nothing to do with the athlete who possesses them. It's an uncomfortable fact for democratic societies that things are not randomly distributed. Human life is a gift, not an achievement. You make the best of the genes that you've got. What about enhancing ourselves, reinventing ourselves? Enhancement. Is there a clear line between enhancement or therapies? Well, I wear glasses. They enhance my my eyesight. The World Health Organization defines health as a complete physical, mental, and social well-being, not merely the absence of disease or infirmity. Wow, that's a bold statement. And we all do other things to enhance ourselves that are non-genetic. We may take nutritional enhancements or pharmacological enhancements. We may take exercise to enhance ourselves. Is there a fine distinction between enhancement and therapy? Some people, as they are born with inherent advantages. Should we try to therefore level the playing field? After all parents, don't they want to wish the best for their children? They dream that their child's going to be, I don't know, a Nobel Prize-winning scientist or a great poet or the prime minister. Well, maybe nobody would choose that these days. Could parents maybe upgrade the athletic prowess of their children and give them better opportunities? I'm never going to be a great athlete. I don't have the right genes to do it. It wouldn't be introducing new genes, but shuffling the pack and giving a good combination of natural genes. As a good fun for a science fiction read, I like this book by Peter James called Perfect People. I won't spoil the conclusion of that for you, but it's Be Careful What You Wish For is its subtitle. Should we edit the human genome for, say, increasing intelligence, vision, athleticism, musical ability, beauty even, if we could do that? But it makes our children into commodities rather than precious gift. Again, Francis Collins says the application of germline manipulation would change our view of the value of human life. If genomes are being altered to suit parents' preferences, do children become more like commodities than precious gifts? And we'd be in danger of breeding humans from mathematical or musical or athletic ability. What would a teenager say if they understood that their parents are genetically modified? And you did that to me? What? How dare you? And how would you respond if you knew you had been genetically modified, or might we even put it, commodified? We might use the phrases begetting or making. Begotten, not made, as part of one of the creeds describing the second person of the Trinity. Begetting has a more personal, non-manipulative aspect to it, an aspect of mystery into the child's future, rather than the technological making, reducing children to products of our own created with maybe false expectations of what the child might become. Doesn't matter what athletic genes the child may have, if they choose to be a couch potato and not to exercise, it's not going to make a great deal of difference. It will alter the relationship between the child and the parent. What about the possibility of even selecting athletic teams? I came across this published in a newspaper that I don't generally read about football clubs testing its players to see who was more injury prone. And I thought, that's a bit of nonsense. Until a few years later, I read an article in a scientific magazine, a piece of real science, that says there are genetic differences that make some people more prone to injury than others. So you could test your child at an early age and say, no, don't bother becoming a footballer because you're never going to make it. You're going to be injured. You'll be on the bench all the time watching that. Would we want to do that? It removes that fun, that contingency from life. The enhancements we can have now will be out of fashion by tomorrow. Parents might want to keep up with the latest genetic fashion, and today's enhanced child will actually become yesterday's child, as life 2.0 becomes life 3.0. At what stage should you have a child? There's also not a great leap from between saying to somebody you can have a genetically improved baby to saying you must have a genetically improved baby, because to not genetically improve them will be a drain on society's resources. And I'm rather moved by this statement from Arthur Kaplan, writing in Time magazine, who brings it home to you and me. Renegade scientists and totalitarian loonies, he says, are not the folks most likely to abuse genetic engineering. You and I are. Not because we're bad, but because we want to do good. Parents understandably want to give their kids every advantage. The most likely way for eugenics to enter our lives is through the front door, as nervous parents, awash in advertising, marketing, and hype, struggle to ensure that their little bundle of joy is not left behind. And we run the risk of the gene rich, which actually will inevitably be those who are economically rich, becoming a separate species. Techno-selfishness, as somebody put it, faster, brighter, stronger. But it's also been pointed out, high IQ, high strength, high ability doesn't actually correlate with high moral values. That suggestion it does is absolute nonsense. And rather than making better people, we have just made enhanced humans. And C.S. Lewis foresaw some of this, writing The Abolition of Man, wrote that man's power over nature then turns out to be a power exercised by some men, and I think that means men and women, over other men with nature as its instrument. We use science to dominate or to control each other. So just in closing, let's think just a few things about the Christian response to us being made in the image of God. Made in the image and likeness of God, as other speakers have already said. Genetically, we're 98% similar to chimpanzees. That does not mean that chimpanzees are 98% made in the image of God. Our DNA is not what defines that. After all, God is spirit, not flesh and blood. Our interaction with God is relational, rather like the relationship between the three persons of the Trinity, not biochemical and genetic. Creativity is part of the image of God. We are God's co-creators. But being made in the image of God concerns the whole person. And genomic variation, environmental influences, personal choice all play a big part in that. It's the whole person who responds to God. Genetic variation is another part of the wonder of being made in the image of God, where all of us are made in God's image, not just the special ones, the kings and the leaders, with each person being of worth and loved by their Creator, because we're all made in his image. We are made in God's image, but we need to be careful we are not God. And being made in God's image says that all human persons have worth and dignity, regardless of what they can or they cannot do. And I close with these words from the Psalms. The psalmist, who knew nothing about genetic technologies, nothing about genes or cells or chromosomes, talked about the wonder. You created my inmost being. You knit me together in my mother's womb. I praise you because I'm fearfully and wonderfully made. Your works are wonderful. I know that full well. My frame was not hidden from you when I was made in secret in the secret place, when I was woven together in the depths of the earth. So I've said far more than enough. I've gone a little bit over time. Let me recommend a few things for you for reading. The Christians in Science have produced a series of books on thinking about, and there's two that are relevant to what I've been talking about today, Genes and Embryos and Human Enhancement. And there's my own book, Modifying Our Genes, produced with Alexander Massman, who is a philosopher, theologian. I don't know if that's on the bookstore for those of you who are in person, but if not, it can be purchased from the Faraday website from the shop. And at that point, I will stop and we'll take some questions. Thank you for listening.